Hello, my name is Ria Malpani. I'm in 10th grade at Daffodil International School, and my topic I chose for this chemistry project was fuels, and my model was the fractionating column. Before we go into the model, I'll talk about what fuels are and what I found from my research and survey. So we know that fuels have had an influential impact on societies for centuries. They currently are the main source of energy, with fossil fuels taking up around 84% of the world's energy input. There are many uses for such fuels, which will be detailed now. In fractionating distillation specifically, crude oil is separated into different fractions, such as bitumen, which has a boiling point of 400 degrees Celsius. It's used for roads and roofs. Fuel oil, which has a boiling point of 370 degrees. It's used for ships and power stations. Diesel, which has a boiling point of 300 degrees. It is used for cars, buses, and other vehicles. Kerosene, which has a boiling point of 200 degrees Celsius. It's used for aircraft. Petrol, which has a boiling point of 50 degrees Celsius. It's used for cars and other automobiles. And lastly, we have refinery gases with only a boiling point of 20 degrees Celsius, which makes sense because it exists as a gas at room temperature. It contains ethane, methane, propane, butane, and other light hydrocarbons. So one clear observation you can make when you see this fractionating column is firstly that it's more colorful than your traditional fractionating column. And secondly, as you go up the as you go up the fractionating column, the boiling point decreases. Now, the reason for this is that if you analyze the molecular structure for each of these fractions, you will notice that the number of bonds between each atom decreases. So refinery gases such as methane, for example, has a less number of bonds than bitumen, which has an innumerable amount of bonds if you search it up. The reason for this is because in order for a substance to boil, all intermolecular bonds must be broken. This means that it requires a lot of energy for each bond to be broken. Now, energy and temperature are proportional to each other because temperature is just kinetic energy. So basically, if you consider it that way, bitumen has a lot of bonds, which means it requires a lot of energy for it to boil. This means that it requires a high boiling point for it to actually boil. As you go up, bonds decrease, boiling point decreases, and at the end, refinery gases, it has a very small number of bonds, which means it requires a very small amount of energy to actually boil. Therefore, it's very less. So initially, the fractionating column is heated at 400 degrees Celsius, and as the temperature decreases, we can observe that different fractions are being formed. Overall, I did conduct a survey over this topic, and I found some very interesting. I heard a lot of interesting insight from a lot of people. But overall, usage of these fuels are greatly prevalent across the world, and we depend on these fuels for an innumerable amount of tasks. We need to focus on shifting from these fuels to more efficient methods of energy use so that we have a cleaner and healthier planet in the future. It is not effective for us to merely look at statistics and dwell on the frightening numbers, or read the catastrophes present in the newspaper about climate change. That is the first step, but the next step is to figure out what we can change and improve. That is up to us as the younger generation, and that is what our motive will be. Thank you for listening.